Hello. Hello. People are coming in. Good morning. Just so you know, there's about a 10 to 15-second delay on this stream. So there should also be an option for you to chime in and say something in the chat. Feel free to test that option. So there's about 9 of you right now. I should say 10 of you that are watching the stream. So again, it's only me. I'm not going to hear your voice. I'm not going to see you. That's not what this is about. We're trying to make the best of a situation. Hello, Leanna. Hello, Cindy. Good morning. Okay, so does everyone have access to the materials? That's number one. Hey, Josh. So I'm working with 2 computers right now. It's really, really crazy, but we're going to try to make this work to the best of our capabilities at this point. You know, just keep positive. You know, definitely an interesting time. Most important is that everyone's safe, healthy, and really at this point, what more can we ask for? And I hope you enjoyed the little public service announcement. It's going to go a long way, although it's, you know, kind of comical. It's really important that we follow that. If a raccoon can do it, we can do it. All right, so I guess everyone is good. We have about 16 watching. I think the roster has about 27 or 28 of us. The show must go on. So I'm hoping that everyone saw the link. So again, there's about a 10 to 15-second delay on this live stream. Only you can hear my voice. Only you can see the window that I've shared. I cannot see you. I cannot hear you. How I will interact with you will be on this chat, the one that's on YouTube. So if everyone's ready, everyone I hope downloaded the material for today, chapter 2 materials. We're going to be looking at composite functions or composition of functions and domain. The only thing that's going to be a challenge for me is that the way that I present the slides or the PowerPoint. I'm not able to do it piece by piece, so the way that you're going to see it today is all in one shot, so it could be kind of overwhelming. But what we're going to be looking at, again, as I mentioned before, are composite functions. So we looked at the last time that we met, which was Friday the 13th, March 13th. We were talking about functions, we're looking at domains, we're looking at inputting certain domains into various functions and having an output, or a range, if you will. So what we're going to be looking at today is essentially the same thing. However, we're going to be doing multiple functions at the same times, or a composition of functions. So the notation is as follows. So right now we're looking at the slide which is presented to you on the YouTube stream. Can someone just say hello, that this is working, that you can hear my voice? That would be great. I don't need all 20 of you, just one person to say that you can hear me. Great, thank you, Brittany. Awesome. All right, so the notation looks kind of funny. So what you see in front of you right now is G, and then it looks like this degree symbol, and then the letter F. So it's properly said as G following F. So in other words, right now you see G first. It's not what you're going to be doing first when we're actually trying to evaluate a function. So what's going to happen is that we're going to evaluate the f function first, whatever that is. We'll have an answer for that, and then that answer will get evaluated into the g function. So just reading along in the actual slide, the domain of g following f is the set of all numbers x in the domain of f such that f of x is in the domain of g. So this sounds kind of crazy right now, but when we look at some examples, it'll become a little bit clearer. Let me just go into changing. So the first example. So again, here one of the drawbacks to this is that you're going to see everything all in one shot. So which may be beneficial rather than detrimental. So if we look at this example, I hope that you have your notebooks out, that we're actually following along, because that's going to be helpful. The visual is one thing, but if we're not really doing it, then I think it will be less impactful. So this should be the first example. And also, if you can confirm that you have access to the materials. Can someone confirm that? That someone downloaded the material, both the PowerPoint and the actual classwork? I just need one person to confirm that. So again, okay, great, Brittany. Thank you. So it's live, it's there for you. Take advantage. You don't have to print it out, but at the very least, please follow along. So I'm hoping that this example is there in the classwork. Can someone confirm that the example that's in the classwork that I've shared on a Google Classroom, that it correlates or corresponds to this problem that's up? I just need one person to confirm that. So again, the question that I have, in the classwork section in Google Classroom, or whatever file that I uploaded, that's the document itself, is this, or do you see this problem in that document? Good morning, Irene. Great, thank you, Brittany. I think Brittany is the voice of the classroom. That's fine, thank you for that. So, here we go. So we have these two functions, f of x equals 2x minus 1, and g of x is equal to 4 divided by the difference of x and 1, or in plain English, x minus 1. So what we want to do is we want to evaluate the function where it's set up as f following g of 2. So we want to evaluate 2, or this value of x, in g first. So once we evaluate that, then we're going to have g of 2. So if you look at the solution, it says first find g of 2. So since g of x is equal to 4 divided by x minus 1, we simply just plug 2 into that function of g of x. So hopefully you saw that 4 was pretty simple to come up with as an answer. Or just 4 divided by 2 minus 1, which is just 4 divided by 1, which equals 4. So now that we have g of 2, which is 4, we evaluate f of 4 now. But since f of x is equal to 2x minus 1, that becomes 2 times 4 minus 1, which is just 7. Any questions so far with this? Or does anyone need clarification? So just another thing, you can message me on the side if you don't want to make your question public. You can use the Google Classroom. So you can send me a message in private if you want me to clarify something. It could be anonymous, so this way you don't feel, embarrassed or whatever if you have a question that you think, I don't know, that might not, that you don't want to share with the class. So feel free to use that. But if you don't mind sharing a question publicly, please feel free to use this YouTube live chat. So are we clear with the following. Are we clear with example 1? Thank you, Valentina. All right, moving along. So that was example A. So if we look at example B, so it's essentially the same two functions that you're comparing, but now the only difference is the following. G and F are now switched, and now we have a new value of X that we're evaluating. So again, just something to think about. Don't confuse this composite notation with multiplication. It's really pronounced F following G of -3. So in other words, we're going to evaluate in this case, let me see, is this an error here? No. I'm not sure why that came up. That might be an error. Yeah, that's definitely an error. Apologies. So right now it says F of G. It should really be G of F. So I spotted that. It'll be a little tough for me to correct that right now on the spot. But I believe that what's after the equals is correct. So that notation where the arrow is pointing to F of G, it really should be switched. So please ignore that for now. So we're just looking at everything to the right of the equal sign. So we're evaluating first F of -3. So let's see here. What's going on? Just give me 1 second. Okay. All right, so if we evaluate F of -3, plugging into F of X, that should give us -7. So the only thing is that here it's not shown in the example. So clearly if we were in the classroom, I would be able to easily plug into F of X, F of -3. So if you plug that in, it becomes 2 times -3, or -6 minus 1, which is -7. So just something for you to be aware of, that F of -3 equals to -7. So when we now evaluate -7, that will go into G of X. So it becomes 4 divided by -7 minus 1, which will just all simplify to -12. So again, just to go back, the notation was off, where it's pointing to that little box with that arrow, for lack of better words. That F of G should be switched. That's a typo on my end, but everything to the right of that should be correct. So the final answer after the evaluation should be -12. Okay, moving along. So this is where it's going to get a little bit confusing, because we can easily evaluate. That's really less of an issue here. The issue now is going to be kind of like the last time when we looked at this, figuring out a proper domain. So if we have here f of x, now this is different example than from number 2. So we have f of x is equal to 6 divided by x minus 3, and g of x is equal to 1 divided by x. So what we want to figure out is the domain when we actually perform this composite function. So if you look at the solution, or how it's laid out, we have f following g of x. So wherever x is, which is kind of different than the previous example. Before you had a real number, it wasn't a variable. I think we're just looking at integers. So in this case, we're actually plugging in what g of x is into f of x. So in other words, 6 divided by x minus 3x for g of x is 1 divided by x. So that's why in the denominator for f of x, you have that fraction. So it becomes 6 divided by 1 divided by x minus 3. But now you may be wondering to yourself, how did we go from the top example in the solution to the bottom? So essentially what ended up happening was we found the least common denominator, and we wanted to get rid of the fraction in that denominator. So everything after we multiply x to get rid of that fraction, it will simplify to 6x divided by 1 minus 3x. So all you have to worry about right now is that top piece, through some algebraic manipulation, for lack of better words, results in 6x divided by 1 minus 3x. So essentially what ends up happening here is this. So what we need to do is we need to now identify the domain. So the domain of G. So the domain of G is all real numbers except 0. So that should be pretty clear, right? Because if we plug in 0 for G of x, it becomes undefined. The domain of F, just by itself, now we're looking at the individual domains. So the domain of F, right? It's all real numbers except 3. Because if we plug in 3 into f of x, we'll have an undefined fraction. So just to be clear, g of x, right, cannot be 0. F of x cannot be 3. So the expression g of x therefore cannot equal to 3 also. Because if we plug that in, so this is where it's going to get a little bit complicated. So we know individually, g of x, again, I'm just repeating myself. G of x cannot be 0, undefined fraction. F of x cannot be 3, undefined fraction. But if we made g of x into 3, so the expression g of x therefore cannot equal to 3. So that whole expression, because it's going to result in an undefined fraction. So if we look at the entire piece here, right, because that's looking at it individually. But now if we look at it together, we can solve for that denominator that we found, which was 1 minus 3x. And if we set that equal to 0, because again, we don't want an undefined fraction, we're going to see that x will equal to 1/3. So let me go back and clarify what I just did. I looked at the individual functions. We identified values of x that will make the functions undefined individually. But when we look at the whole thing together, when we're looking at f of g of x, so basically the composite function, when we look at that, x cannot be 1/3. So again, it's essentially solving for 0. So here's something to consider. G of x cannot be 0. Right? So therefore, when we're looking at this entire domain, so f following g is the set of all real numbers except 0 and 1/3. So the reason why it's 1/3, again, so you might say, oh, why can't it be 3? So if we substitute 1/3 into g of x, that's going to become 3. So that might be a little bit confusing. So let me repeat. So basically, for this domain, it can't be 0 and it cannot be 1/3. Imagine plugging in 1/3 into g of x. So just follow along with me. So again, as we move along through this whole remote learning, at some point, I'm going to try to have some digital whiteboard so I can make this a little bit easier. So this is day 1. I apologize. Clearly, there's going to be some hiccups, and I thank you wholeheartedly for your patience. So again, try to follow along. Imagine you substitute into g of x 1/3, so g of 1/3. If that evaluates, it's 1 divided by 1/3, which just becomes 3. But we cannot use 3 because if we look now at f of x, then that's going to become undefined. So to basically sum up everything that I just said in very little or very few words, 0 and 1/3 are not a part of this domain. So you can write it in the notation that you see here, or you can just write all real numbers except 0 and 1/3. They both mean the same thing, but I want you to get used to that notation. Again, if you have any questions, I don't know who's Christopher Tester. Oh, okay, one of these issues. All right. All righty. So moving along. So now we're going to look at the same example, but now we're just changing. We're changing the composite function. So before it was f of g of x, now it's g of f of x. So now if we plug in, notice the evaluation. And it says here, note that this is meaningless if x equals to 3. So that's where we have to be careful. So if we let x equal to 3, then we're dealing with an undefined fraction. So I'll give you a second just to process all of this. Hold on, I have a question here from Valentina. Sorry if you sent this like a minute or two ago. I'm working with 2 screens. Would you ever get a number for g of x that wouldn't make the fraction for f of x undefined? So let me read this again. Would you ever get a number for g of x that wouldn't make the fraction for f of x undefined? So we know a number that will make g of x, let's see. So for example, if we made g of x 1, right? Would you ever get a number for g of x that wouldn't make the fraction for f of x undefined? So as an example, so I guess you want to go back here, Valentina. I just want to make sure that your question is referring to the previous example. So are you still talking about this example here, Valentina? Okay, so let's pretend that g of x equals to 1, right? Because you're saying, would you ever get a number for g of x that wouldn't make the fraction for f of x undefined? So I'm using 1, right? So if we have g of 1, then it's 1 divided by 1, which is just 1. So that we would put into f of x, right? So then it becomes f of 1. But if we evaluate that, then it's 6 divided by -2, which then will result in a value or in a function that's defined versus undefined. Does that answer your question? Thank you for your question. All right, so moving along. So if we go back to example 3. So again, we're just evaluating, but the only difference here is that we're now switching f and g. So before it was f following g, now it's g following f. So we just want to see if there's any real difference in how our domain looks like. So when we substitute in, again, we're dividing a fraction with a fraction. Essentially, it's keep, change, flip, which is why 1 divided by all of f of x essentially becomes x minus 3 divided by 6. But if we use 3, it's going to become undefined. So if we look at the following, the domain of f, right? So when we're simplifying all of this, the domain of f is all real numbers except 3. And the domain of g is all real numbers except 0. So the expression for f of x, which is 6 divided by x minus 3, is never 0, since the numerator is the non-zero number 6. So in other words, they both work together. So if I go to the next slide, this is a little bit abstract, slightly. But if we look here, the domain of G following f is a set of all real numbers except 3. So we're looking at the final evaluation here. So the final evaluation, individually, you can say, oh, x cannot be 0 for g of x. Oh, f of x cannot be 3, as an example. However, when you're looking at the entire domain, the entire evaluation, which is what we have up here. So this piece, x minus 3 divided by 6. We're going to exclude the value of 3. Because if we include it, then we're going to have an undefined fraction. So in other words, when we look at this, the domain is basically all real numbers except 3. So with all that said, I've spoken a lot. Actually, I've been talking nonstop for about 30 minutes. Does anyone have a question? Another question for you. Do you guys like this? Please be honest. Yes, Josh, that was literally a fraction within a fraction. I feel you. I mean, look, it's ideal. Look, I'm going to try to make this work the best that I can. We're in an unfortunate situation. We're forced to work remotely. Um, Definitely, think about some things that you would like to see, and I'll try to implement them the best way that I possibly can. Right, I agree with you totally, Brittany. So right now, I do not have that. I'm going to try to figure out a way where I can have a digital whiteboard. So this way I can actually provide immediate feedback and actually do some type of equation or some type of evaluation to make it a little bit easier. So right now, I'm also limited into the technology that I have. Literally, we were thrown into this, and very few of us have the technology to run a digital whiteboard. I have an iPad, but it's a little bit older, so I'm going to see if there's something that I can do with that. But this will be evolving. I definitely want this to improve, and I want it to be meaningful for you guys. Don't forget that. So let's see. Elizabeth, you wanted me to go back to a slide. Or Lenny, I'm so sorry. Lenny, can you go back to the slide with the explanation? Yes, I think this is the slide. So if you feel comfortable, I want you to try questions 1 through 7. We still have about 15 minutes in this class, just so you know. I believe it ends at what? Is it 45 or 42? So does this class end at 9:45 or 9:42? Okay, so take about 10 minutes. There's 7 questions there. For our discussion, let's say here 1 through 5, given function that you find. Answer 5. Answer 5, any 5 that you'd like to answer. So now the thing is this. Now, how do you guys work together? Certainly use this platform if you want to. I'm sure you have each other's numbers. I'm sure you may be even video conferencing, which is cool. If that's how you want to work as a group, be my guest. But again, I will never be video conferencing with you guys. That's just part of Academy's policy. I'm sorry. So this is the best that you'll get from me. My voice and some type of video streaming the slide. But feel free to use this platform if you want to chat, if you want to create a group chat. I'm sure you guys have FaceTime. You can do all of this. So again, pick any 5 that you want. I'm going to give you the solutions to that in about 10 minutes. So right now I'm going on silent for a few minutes, but I'll be back in about like 3 or 4 minutes. So if you have any questions, just let me know. Any questions so far? Can you guys still hear me? Okay, cool. So also, FYI, if you heard some noise, I was just making some coffee. The microphone's very sensitive. Um, but if you'd like, you can take a picture of your work. You can share it with me in Google Classroom. We can try to present that or project that so we can talk about it. So again, this is an evolving process. Um, it's not perfect. It will become, more perfect each day. Thank you again for the suggestions. I'm going to try to see if there's some type of digital whiteboard that I can use. If you guys, if you know of something, you can definitely recommend it or share that with me. Again, we're all kind of in this together for the first time, so we can only benefit from what we each know. So again, you're also finding the domain for each of these. So you were to pick any five. We have about 2 or 3 more minutes. And throughout the day, as you do this with your other classes, if you see something that's being done that you find really effective, that works much better than this, please share it with me at some point. If you see a teacher using a digital whiteboard or something that's like slightly more interactive, please let me know. Share it. You can email that information to me because again, I want this to be almost as good as if it were live. Obviously, it'd be great if it could be better, but you know, we'll make do with what we have. How do we share work again? Okay, you can share it. It depends on how transparent you want to be. I believe you're able to post something in the actual Google Classroom. You can share it with me. You can send it to me via email, Alarcon Math. I think you can message me privately in the classroom. For example, I think I can do that. Hold on. You're going to see something from me, Josh. Hold on. Where are you? Um, Hi. Please share the picture here. So I just sent something to you, Josh. So now this is an interaction that should be just you and me. Did you see the message on the Google Classroom, Josh? So great question, Elizabeth. So yeah, so there should be homework in the Google Classroom. You can do it on a separate sheet of paper, and at this point, the best thing to do would be to submit it to me via email. You can send it to the Google Classroom, I believe, messaging. If you feel comfortable, you can use Jupyter. So That's the one issue. There's a few platforms that we have here, right? Which I mentioned in an email. The platforms being this Google Classroom, Jupyter Grades for keeping track of grades and general messaging, and then you have Lumen Learning. So there's going to be three things that we're using. Ideally, I would love to be on one platform, but that's going to take a little bit of time to transition into a single platform system for all of us. So for now, we're going to kind of juggle between the three. So Lumen Learning, as of this point, that's going to be our main way that I will assess you, whether it be homework or quizzes, just so you know. Jupyter will still be the main source for you to see your grade and to send me messages if you'd like. And Google Classroom is going to be the main way that you're going to be taught. Okay, so just because of time, I'm going to share this with you now. And at the end of this discussion, excuse me, I'm going to just send you, or I'm going to upload all of chapter 2. I think we're done at the conclusion of this, yes. So I'll send you all of the solutions, the entire PowerPoint that I went through in class. It's going to have all of the solutions to also the previous chapters or sections that we spoke about within this chapter. So if there's something here that you feel that you missed, I wouldn't be too concerned because I'm going to include everything as soon as we're done with this. So to answer Leanna's question, there's homework that's a part of your Google Classroom. If you go to classwork, I believe it's chapter 2. If you click that, there's the materials. There should be a homework also. You just have to click on it. So there was a PDF. There's 3 PDFs. So one of them was the PowerPoint, which I gave you a light version of it. And then you should have had the classwork, and then there's a homework. So for tonight, your homework is going to be to complete that handout. So there's no Lumen Learning homework tonight. So the only homework that you have, well, I did assign Lumen Learning last week, so that's just review stuff. And I think I set a due date for that. I want to say it was due yesterday. But this homework now, the homework that is going to be due for tomorrow morning, if we want to put a date, so here, a time. I mean, if you think about it realistically, if I were in class, I would be physically checking these homeworks. So the only thing is this. Let's see. I think to make things easier, I'm going to post something here right now. Hi all, for tomorrow, please submit your homework by 8:30 a.m. I think that's fair. I mean, if you're done with it like in 10 minutes, send it to me. That's fine. You can send it to me through Jupyter. I think that's one way that we can easily communicate. You already have everything set up. It's not really any extra work. Because I'm just concerned that if you share something here in the classroom, again, this is also new to me. I don't want you to necessarily broadcast your work to the entire class. So for now, just submit it through Jupyter. Yeah, and that's a problem. It's funny that you said that. Yeah, so in regular classes that are not academy, in every other New York City public high school, for the most part, classes are about 45 minutes. So just think about what we get done in 80 minutes. I know you guys complain, but the grass, you may think the grass is greener somewhere else. You should enjoy the fact that you have 80 minutes. Trust me. You get a lot done. But we did get a lot done here today, I think. Can you send us the answers for the classwork, please? Absolutely, Dahlia. I'm going to submit all the solutions to you in about a minute because I'm going to let you guys go. Class is over. So I'll just stay tuned. I'll have announcements on the Google Classroom, and we'll continue this discussion tomorrow. A great first class again. If there's any suggestions, if you see something that ran a little bit better today in your other classes, please share that with me. I want to make this the best experience for you possible. And with that, I'll see you tomorrow. Be safe, be healthy, and see you soon.